Welcome to BioSumit friends. Today we are going to have the second part of optimal foraging theory. So in the earlier part we have discussed about some points on optimal foraging theory. If you haven't watched that video, you can have the link in this description box. And you know that foraging means uh, it's a balance between a food's energy content and the cost of obtaining it, right? So we have discussed this in terms of P is equal to E by T in the first part of the video. P means profitability, E means net energy value of the food, and T is the time investment, time invested in obtaining and processing the food. So with that equation, according to that equation, we have learned 3 points in the earlier part of the video, that is energy maximization, marginal value theorem, and central place of origin. So today we are going to have some other points. Like the first point today is risk sensitive foraging. Risk, actually here risk sensitive foraging means risk versus reward thing. Like you can see here that animals often face risks while foraging, such as predation or competition, right? Or it can be scarcity of foods too. But always the optimal foraging theory takes into account this risk versus reward thing. If the rewards is more, sorry, if the rewards are more in comparison to the risk, then it will go for the foraging, right? So you can see here that between the potential rewards and risk associated with different foraging strategies. Okay, so this is risk sensitive foraging. Next point is informational learning and pack selection. So optimal foraging theory actually recognizes the importance of animals' ability to gather and use information about its environment. Okay, so it needs to know some prior knowledge to forage in a particular area. Okay, so that it can adjust in that place or it can leave that place. Okay, so that type of informational learning is needed uh, to survive in one patch. Okay, to go for foraging. And patch selection, you can understand it in terms of MVT or marginal value theorem, that it should know when to leave and when to remain in that patch. Okay, if the food and the foraging substances will be very less in that place, or the risks are getting higher in terms of rewards, so it has to, one animal has to leave that patch, right? So you can see here that I have written it, that decision to stay in a patch, wait, having a pointer. The decision to stay in a patch or move to another is influenced by the diminishing returns outlined in the MPT. So in terms of MPT, you can describe that patch selection. Okay, so in any animals, okay, even in humans, you can see this theory being applied. Okay, including insects, also birds, mammals, and obviously it can give a framework to understand the ecological and the evolutionary factors. Okay, for influencing the foraging behavior in different species, different environments, in different conditions. Okay, so that's why here the term patches come. Okay, when some if the factors are getting hampered or affected, so in that way the framework will be changed. Framework means for the living or dwelling or staying in that place, in a particular place, that can be changed. Okay, on the basis of that evolutionary factors and ecological factors. Now, right now, there are many scientists and researchers. They are using mathematical models, empirical studies to test and refine predictions derived from wave. So this is all about optimal foraging theory in terms of, remember one thing, that optimal foraging theory is actually says about the balance between a food's energy content and the cost of obtaining it. And we can easily understand it by the equation of P is equal to E by T. That means P should be higher in terms of going for that particular conditions. P will be higher when E is higher, that is energy value of the food, or T is lower, T is the time investment to capture the food. So this is all about optimal foraging theory. See you in the next video. Thank you.